Hello, in this mini lecture I will introduce another three codes for numbers, and BCD and gray for non-negative integers, and fixed point for real numbers. Okay, let's start with BCD. BCD, its name is for binary coded decimal. It is a very simple code to express decimal number into binary, because let's start with an example. Let's go 3. Okay, in binary natural code you would have to divide it by 2 and write down the remainders, and there would be a lot of work. But in the case of BCD code, you simply encode each digit separately using 4 bits. So 0, 1, 1, 1, it is a 7, 0, 1, 0, 1, it is 5, 0, 1, 1, 0, it is 6, and 0, 0, 1, 1, it is 3. So then you put these sequences one after another to get the resulting sequence for BCD code of this number BCD. If you'd like to get the reverse, so express something which is expressed in BCD, have to be expressed in decimal, you simply divide the sequence into 4-bit chunks, and in chunk is expressed using one decimal digit. 3, it is 6, it is 5, it is 7. That's all. What about gray code? You know gray code from Carnomap, but in the Carnomaps you had 2-bit only representation, which is the following. If you'd like to get a 3-bit gray code, you simply mirror 2-bit gray code, and then put half zeros and half ones at the position of an MSB, most significant bit, and you've got gray code, which is 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, and 1, 0, 0. Look, pay attention on this feature. And last and the first differ also in one position. Oh, sorry. One position, not this, but this one. Oh, yes, and they differ in this position. Only one position. And this is the feature, the feature of the gray code. Yes, the consecutive and the last and the first sequences differ in one binary position. What about the real numbers? Let's start with this. Okay, it is a decimal number, and your task is to express it in binary. So instead of when you express integers, non-negative one positive integers, you divide the number by 2 and you write down the reminders. Here you must multiply and write down the integer part of the result. So let's start with this number and let's multiply it by 2, and the result must be expressed into 1, which is an integer part, plus the remainder and the fractional part. It is a 0.375. Okay, this was very important. And then you take this part, okay, don't need the fractional, and multiply by 2 again, and express the result in the same manner: integer plus fractional. And do the same again. It is a 1 plus 0.5. And again 0, sorry. It is a 1 plus 0.0, and this is a stop condition. Okay, if you get 0.0 in the fractional part, you stop algorithm, and you express it in this manner, not the opposite as in the integer numbers, okay, but in the consecutive, starting from the first. So 0.1011, that's the result. If you like to express this in decimal, you simply denote that this is a 0 power of 2, this is a -1 power of -2 power of 2, -3 power of -4 power of 2. And then you simply write that this is equal to 1 times 2 to the power of -1 plus 1 times 2 to the power of -3 plus 1 times 2 power of -4. It is equal to 0.5. Yes, it's just a 2 to the power of -1 plus 0. How much? 1, 2, 5 plus 0. It is a 2 to the power of -2, which is a 0.25 times 0.25 is equal to 0.0625. 0.0625. It is equal to 0.56. Then 2, 6, 8. Then 5 and 2, 7, and then 5 in this one. Quite complicated. But it is a fixed point representation. How to express this in decimal systems, in digital systems? You don't have any other symbols than 1, 0. So you must, for example, express this in a 8-bit encoding. You must know where the comma is placed. Okay, it is an agreement, it is a standard. Let's say it is after the 4th bit. So you must put 0, 0, 0, 0, then it is a comma which is not present in the systems. It is only agreement, okay? And then you put 1, 0, 1, 1, okay? It is here, but it's not existent. It is not existent. If the comma is after the 3rd bit, you would have something like this. The number would start just after the 3rd bit, 0, 1, 0, 0, and then you put the remaining ones as zeros, okay? And this is here is non-existent, that is here, okay? So it is an agreement or other than the real symbol. In case of plus minus, there is a bit devoted to encoding of the sign of the number. Here, it is only agreement, okay? The compiler should know in advance where the comma is placed. That there is no comma in the representation, okay? There is only zeros or some bits in the integer parts, and then after the standard place, it is a fractional part of the number. Thank you.